Okay, at this point, once again, I assume that you have worked the problem, read it, so we'll dive into the answer. So on part A, find the x coordinates which f has a relative max. So for part A, if f has a max, that implies that f prime goes from positive to negative. So that's my reasoning, because it says give a reason for your answer. That's what I'm looking for. And that occurs, and this is f prime, going from positive to negative at x equals negative 2. I believe that was worth 2 points. One for your answer and one for your reasoning. Part B says, on what open interval containing negative 3 to 4 is the graph of f both concave down and decreasing? So same kind of thing. So if f is concave down, well, that means f double prime is negative. Well, what that means, it means f prime is decreasing. So that's one thing I'm looking for. Okay, if f is decreasing, so here's the second part of the question. That means f prime is negative. Okay, so I'm using these implies here. So this symbol means implies. So I'm looking for when f prime is decreasing and when it's negative. So that occurs, let's see, here we're decreasing and negative. Here we're increasing, decreasing, and negative. So this would be negative 2 to negative 1 or 1 to 3. And that was worth 2 points. Once again, one for the answer, one for the reasoning. Okay, on part C, find all points of inflection. Now be careful because a lot of us missed this on FR1. Okay, give a reason for your answer. So points of inflection occur when the second derivative changes signs, which means f prime, because this is the graph we have, changes from increasing to decreasing or vice versa. Okay, so that's what we're looking for. So that appears to happen. Let's see, we're going decreasing, and then we switch to increasing, then we go decreasing, switch. So that appears to happen at negative 1, 1, and 3. Once again, 2 points. Part D, given that f of 1 equals 3, write an expression for f of x that involves an integral. Okay, this is one you really need to know, and we most likely missed it the first time. Okay, but we're going to use this over and over and over again. Okay, so they give me 1 point and they want me to find an integral for f of x. Well, we know if we take the integral of a derivative that we're going to get the function, but we're going to get FTC. We have 2 parts. So what we need to do is we need to have a variable first. And this is the hardest part. These are actually easier to find than f of x. Okay. So I want to do something from x, but I need a constant here, right? The FTC part 1 says I need a constant. Well, this is my constant right there. They gave me that. Because the FTC part 2 says my antiderivative evaluated at b minus my antiderivative evaluated at 1. The reason we had to use that is because we know what that is. So the integral of 1 to x, f prime dx, is, oh, I probably don't want to use dx, just caught that, so bear with me. Let's use a different variable. We don't want to use the same in these 2 spots. So I'll have f of x minus 3, get f of x by itself. So I have 3 plus the integral 1 to x f prime dt. So there's my integral. And now that I have that, let's find the 2 values. F of 4 will be 3 plus the integral of 1 to 4 f prime dt. And that's where this chunk comes into play. We're told between negative 2 and 1, the area is 9. But be careful, it's below the x-axis, which means it's negative. We're told this is 12, but it's below the x-axis, so it's negative. So from 1 to 4, that would give me 3 minus 12, which is negative 9. Now let's find f of negative 2. 3 plus the integral, you can't change your order just yet, 1 to negative 2. Okay, so that is out of order, so let's switch that. Minus, flip that interval. Okay, so negative 2 to 1 is negative 9. So I have 3 minus negative 9, which will give me 12. That was worth 3 points. 1 for this, 1 for the values. No, excuse me. 1 point for the two values, 2 points for this.